If you can dream it, we can help you create it. Welcome to the You Create podcast, the show that teaches you how to take the power and flexibility of a Stepcraft 3D CNC system and turn your ideas into reality. So let your ideas flow, because we want to know, what will you create?
Hello, everybody, and welcome to episode number 8 of the You Create podcast. My name is Eric Royer, and I'll be your host. Thank you for joining us this week. I'm sorry it's been a couple of weeks since I've recorded last. We've just been crazy busy here and just haven't had time to sit down and put some thoughts together. So I wanted to do this today. It's the day before Thanksgiving. That way I can get it live, and any of you who have time to listen to it over the weekend will be able to do so. So anyway, a couple things that came up over the last couple of weeks that I wanted to discuss that I think will maybe answer some questions for some people. First thing I want to talk about is aluminum. Now, everybody asked the question, can you effectively cut aluminum with a CNC router system? And the answer is undoubtedly yes. Yes, you can. There's no reason why you can't, but there are some things that you need to consider when you're milling aluminum. The first thing is that unlike a CNC mill, like a Tormach or a Haas or something like that, where the head does not move. The head stays fixed, and it's usually part of a very large, heavy cast iron fixture. And the rigidity of that, coupled with a very, very powerful motor, allows you to spin a larger diameter bit at a slower rate of speed and take out more material per pass than you would on a router. Now, a CNC router, like the Stepcraft machine, is a gantry device. So the head is actually what's moving. And because of that, there are some limitations that you have with a router over a mill, and that you don't have the same solid rigidity that you would with a dedicated purpose-built mill. That being said, the main thing that you have to keep in mind is that you can take less material off per pass, and in most cases you can probably move the feed rate a little bit faster than you typically would, because you are taking a little bit of material off. The other thing to keep in mind is that the spindle on a purpose-built mill, like a Tormach, for example, is designed to run at very low RPMs. So, you might be running 3 to 6,000 RPMs. And the tooling that you use is optimized for that purpose. Now, on a router, it's the opposite. The router spindles are usually designed to run at very high RPMs, 12 to 20,000 in that range, sometimes even more. And because of that, you have to look at your tool that you're using. Most people would think they can use high-speed steel because they think it's high speed, and that's really, what they would be using it for. But the case is that high-speed steel end mills are better suited for a lower RPM mill that has flood coolant, and they're just not designed to cut as effectively and last as long as a carbide end mill. So on a router, you're always going to want to try to run a carbide end mill when you're cutting aluminum. Now, some people ask me, do you need a flood coolant system? Well, most routers are really not designed to be able to use a flood coolant because they're open framed. The electronics in some cases are underneath. It's just not a sealed system like a mill that has that type of a cooling system. So as a result, no, you don't need that. There are people that use lubrication misters that you can find online, and from what I'm told, those help with certain types of aluminum. One thing that we do here, and it's actually a new product that we're going to be releasing. We use compressed air, and we have a flexible. Actually, it's a flood coolant hose that's articulated, so you can move it and position it in any direction. They're made for flood coolant systems, but we use one of those and connect it to an air compressor and just blow. We're not using a lot of CFM. It's very low pressure, but it's enough to keep the bit cool and to evacuate any chips that are being cut. The biggest problem that you'll have with CNC router when you're doing aluminum is recutting chips. You want to make sure that you avoid having chips collect near the tool bit or in its path. And that's really important when you're doing a profile cut where you're basically cutting around the material to remove your part. You'll end up with a channel that's eventually as deep as the thickness of the aluminum. And if chips start to build in that channel, you run the risk of either breaking your end mill or having it chatter and ruining the finish of your part, or you run the risk of, depending on the RPM and the feed and speed, you run the risk of welding the chips to the tip of the aluminum and therefore rendering it useless. So it's very, very important that you use compressed air and keep it pointed at the tool bit so that when you cut chips, they are immediately blown out of the way. Now, some people say, well, I have a vacuum system hooked up. Won't that work? We have a vacuum system as well for our Stepcraft machine, and it has a round brush that's magnetically attached to the end of it. And I've tried that before, and it just doesn't do the same job as a compressed air. So when I run aluminum, I actually take the brush off. I don't use the vacuum system, or you could use it, but I don't keep the brush there. I use it so that if there's any chips flying, the vacuum will catch them. But because I'm blowing compressed air at the chips, they're basically being sprayed all over the place, and the vacuum, in a lot of cases, is useless for that. But it's more important to make sure that your tool bit has a clear path with no chips than it is to have a nice, clean work area when you're cutting aluminum. So now the other thing is speeds and feeds. That's a huge mystery for a lot of people. What's the depth per pass I could take? How many millimeters or per second or per minute or inches per minute can I run? What RPM should I run at? What type of tool am I using? I'm not really going to get into all of that here on this episode. I will dive into it more in future episodes and give you specifics. But there are calculators out on the internet. CNC Cookbook has one, cnccookbook.com, that you could actually download. It's a service. You have to pay for it, but it's probably one of the best calculators in existence. And you just basically put the information in about your bit and various different data points, and it's going to tell you how fast to run it for a given RPM and how much depth per pass you could take. Now, I found when using one of these calculators that it's probably 90% accurate for the given machine, and you will get really good results if you follow what they're saying. Now, again, you got to keep in mind that we're running on higher RPMs, so you may put information in and it may say, okay, you can run this job at 5,500 RPM, but if your spindle doesn't go that low, then you have to make sure that you readjust for that, and it'll give you different parameters to run as far as speed or depth of pass, or maybe you change the type of end mill you're using. For instance, if you're using a 4-flute end mill, you're most likely going to run a lower RPM. But if you want to run at a higher RPM, you could switch to a 2-flute or even a single flute end mill, and you'll notice that the RPM setting that it calculates is actually going to increase probably within the range of what your router is capable of. Now, on our machines, we typically run, if we're cutting 6061 aluminum, we'll use a 2-flute carbide end mill, say an 1/8 inch. We'll take about a 0.5 millimeter per pass and run it about 30 millimeters per second. That's usually a good starting point for a Stepcraft machine. Now, the one thing that will affect the speeds and feeds, even if you are using a calculator, is the rigidity of your machine. So if your gantry or your head and the Z-axis, if there's anything that's loose or not perfectly solid, that vibration is going to resonate in your machine. And it will actually prevent you from running your job at the given speeds and feeds. That's one. You run the risk of chatter, a lot of chatter, which will eventually damage your machine. I mean, any excessive vibration on anything is not good. And you can ruin the bits, as well as getting a very poor surface finish on your milling. So you want to really make sure that your machine is rigid. The more solid that it is, the better chance you're going to have to get a good finish, and the more accurate a speeds and feeds calculator will be for you. Now, the other thing that I get asked a lot is, what about types of aluminum? And we just had a client that had a specific job that they wanted us to run, and they sent us some plates, and it was 5052 aluminum, and I've never used this material before. It looks just like any other kind of aluminum that we would use, and basically what they were doing is cutting out these electrical panel plates, and they're looking to prototype them so that they can test them before they go into a production run for their machine. So that's something that our machine or any CNC router could be good for, is for prototyping. I would never suggest a CNC router, or unless it's a really big, heavy-duty industrial one, to be used for large production runs. It's not efficient, and there are purpose-built machines and job shops that could probably do it for a lot less money and headache overall. But on our machine, it's great for prototyping, and that's what we were going to do. So he sent me over an AutoCAD file, and I imported it into Vectric Cut 2D, and I went to create the tool paths. And it was a little complicated because there was a lot of pocketing. There was some recessed areas where there would be labels that were going down 12 thousandths or so. Then there was a lot of holes in it. Some of the holes were around 1/8 of an inch diameter. Other holes were a little larger. So I had to keep that into consideration. And then they also had a countersink that they wanted to run. There was 8 holes on the job that needed to be countersunk. So they sent me a countersinking bit, and we created a tool path just specifically for that. And that created some challenges too, because when you're using a countersink, typically you're going to run the countersink bit down further than the thickness of the material. Because the countersink bit, this one was 82 degrees, they wanted the final opening to be a certain diameter. And in order to get that, when you took the geometry of the bit in play, you would actually have to pass the bit probably 60 thousandths deeper than the bottom of the surface. So you have to make sure you have a spoil board, and that's something you want to keep consideration if you have your aluminum plate on a aluminum vacuum table or on a aluminum T-slot table, and you're going to use a countersinking bit. Be sure that you're using some sort of spoil board, or you'll end up with holes and dents all over your aluminum base. So anyway, I got the whole thing programmed, and we set it up on the machine. I did have compressed air. The plan was to use a 2-flute end mill, and I set it up as we would with any 6061 job that we've done before. And as soon as the bit made contact with the aluminum, the tip welded. Like, it was almost instant. So I said, okay, well, that's not good. And I actually slowed the machine down a little bit, and I put a new bit in, and this time it started to cut a little bit, but then the tip welded again, and then it broke. So after going through about 3 end mills, I did some more research on 5052, and I reached out to a group on Facebook called CNC Router Tips. A new friend of mine, Bill Griggs, is the creator of the CNC Router Tips podcast, which is another great podcast I encourage you to listen to, as well as he created an online group that you could go to. And the people in that community are amazing. And, even though I do this professionally, and when we sell Stepcraft machines, we're always running across new things that I've never done before. So I'm not embarrassed or too proud to reach out for help whenever I have questions. So I put a post up and I explained what was happening. And immediately, guys started commenting, letting me know that 5052 is more common when they use it for bending. It's a softer aluminum. It is kind of difficult to mill on a router. They suggested using MISC lubricant, which I didn't have. They also suggested using a single or an O flute end mill. That would help as well. So the consensus, though, from everybody that was making comments was, why run it in 5052? Why not just use 6061? And so while that made a lot of sense to me, I called the customer and I said, okay, look, I'm having a lot of problems running 5052 on this machine. I'm not sure that it's worth the headache. Why can't you run 6061? And their answer was simply because they've always used 5052. The 5052 aluminum is a little less expensive than 6061. And that was another comment that they had made. But I said, when you factor in the aggravation plus the potential loss of end mills, pretty soon 5052 is going to cost you a heck of a lot more. So I went ahead and I ordered some 1/8 inch, 12 by 12 inch 6061 plates from OnlineMetals.com. And we put the same job in, loaded up 2 flute end mill, and it ran perfectly. It was as if we were cutting wood. There was no welding, no chattering. We had to make some fine-tune adjustments to the speeds and feeds, but overall, it worked perfectly. In a case like this, we actually created, I think this job had 12 tool paths, and I had one for pocketing, hole drilling. There were several different pockets. Each one was a little deeper, so I set those up as a different tool path. Even though they're using the same tool, we did that so that when we tested out the first plate, we can run each tool path file separately and see if we have to make any adjustments on speeds and feeds for that particular process. Then the other part of the job was we had to go back with a 16th inch end mill and go through all of the pockets again, mainly to just kind of sharpen the corners, because they want it as square of an inside corner as they can get, which you can't get with a round bit anyway. But by doing a second pass with a 16th inch end mill, it allowed us to get into the corner and get it a little bit tighter. So then we had one for the countersink, and then we had a final tool path which would cut it out of the plate. And so anyway, my advice is, if you have to do aluminum or you want to do aluminum parts, you can certainly do it with a CNC router. There's no problem at all. I encourage you to get a speed and feed calculator, or join a group like CNC Router Tips or the Stepcraft Crafters Club and post what you're looking to do and try to get a speed and feed starting point from some of the other members. You'll find a lot of them are going to be very helpful. The only issue that I see with asking members for guidance on speeds and feeds, like in a group like the CNC Router Tips, is that they are not going to all be using the same machine as you are. And every machine, like I said, is built different spindle, different power, different rigidity. So something that may work for somebody on, say, an X-carve machine will not work the same on a Stepcraft or on a Shapeoko or a Probotics or something else. So your best bet is to get a speed and feed calculator. And then what I do is, after I run a job, I usually keep a notepad, and I'll say, okay, for this end mill running this type of aluminum, I was able to do a depth of X, a feed rate of X, RPM of X, and I used one thing too that I didn't talk about, and I want to mention real quickly, is setting up a ramp for your job. When you're milling aluminum, unlike wood, you don't want to just bring the bit straight down. It's not a drill bit. You don't want to bury it straight down to your first depth pass and then start cutting. Vectric software and most CAM software will let you program in a ramp. And basically you could say, okay, I want to ramp from the surface of the material down to the first depth of pass in a given distance. So, you might set it to be a half an inch. So now when you're starting that job, it's going to move laterally as the z-axis kind of brings the bit down into the material to your first depth of pass. It's a lot less strain on the end mill, and you're going to get a lot better results. So definitely use ramping when you're working with aluminum. So let's see, speeds and feed calculator, carbide end mills, 2 flute end mill or single flute end mill for aluminum, I find works best. Make sure you have air, compressed air to evacuate the chips. And, don't expect the same results out of a CNC router as you would out of a mill. That's going to save you a lot of frustration and disappointment. And most people that are doing work with aluminum on a router are doing one-off projects, or they're doing prototyping, and time is, you're not under the essence of, having to get a massive production run done in time. So use your router to prototype. And if it is a project that you need to do a higher production run, then go to a specific job shop that specializes in that for getting higher production runs done. So the next thing I want to talk about is on Stepcraft. One of the things that we've been working on is trying to come up with a description of how to describe our machines. And where this is important is, it's fine if I was talking to like-minded people, or if I was in a group on Facebook and I refer to my router as a CNC router or CNC mill, or anything to do with CNC, everybody's going to know what that means. But when you're talking to your aunt or your mother, or just somebody in the general public who has no idea what CNC is, how do you describe your system? The other thing is, some people, when they hear CNC, especially if it's an older person that maybe has worked on them in the past, they think numbered tape, they think G-code programming. So CNC to some people is a pretty scary description of your machine, and they think it's computerized, and how do I work on it? It's going to be a lot of trouble, and all those things. So being that our machine works well in a variety of different applications, from industrial and commercial prototyping all the way down to just the home hobbyist, or somebody that's into crafts, that sort of thing, I needed to come up with a description for the machine that was not so scary. And I put it out on our Facebook group just to see if I can get some suggestions from people. And the one that we ended up with, which is starting to grow on me, is calling it an all-in-one creation system. Now, the all-in-one comes from the Stepcraft having the universal head attachments, which makes it nice because you can go from milling to 3D printing to engraving to hot wire cutting, etc., simply by changing out the head. So because we're one of the only systems on the market that has so many different attachments for it, the all-in-one part seemed to make a lot of sense. The creation system came just simply because that's what you're doing. You're using the machine to create things. So I mentioned it on this podcast because it's funny, and I'm really curious to all of you out there to see how you describe your system to somebody that is not familiar with these machines. So, what do you call it? How do you describe it? I'd really love to know that. And if you have a chance, please drop me a comment on the page at ucreatepodcast.com/008. Or you can send me an email. That'd be great. I'm just curious how everybody describes their machine. Now, another thing I wanted to announce, actually the last thing on this podcast, because we're slowly running out of time, is I want to talk about a new program that we put into place at Stepcraft. Now, we had a very busy year this year. Since Kickstarter, we've established a lot of new customers, probably better than 500 new customers that are happy owners of Stepcraft systems. And I want to keep the momentum going, and I want to keep getting the word out to everybody about our machines. The problem I have is that, we're only 3 people here in Connecticut at the Stepcraft USA offices for now. And I tend to spend an awful lot of time with people on the phone. I want to be sure when somebody's interested in buying a Stepcraft system that I spend as much time as they need on the phone to answer all of their questions. And in most cases, those phone calls generate more content for me to talk about here on the podcast. So because of that, during the course of a 8 or 10 hour day, I may only have time to reach out to and talk to 5 or 6 people throughout that day. So I needed to come up with a plan to help spread the word and to help get more people, calling and interested in Stepcraft. So what I did was I set up an affiliate program, and basically all you have to do is go to stepcraft.us/affiliate, and you could sign up. It's free. You fill out a form, and basically what will happen is you'll receive a URL that's specific to you. And anytime you mention Stepcraft and you provide a link back to our website, just use the custom URL that you were given. And what'll happen is, say you put a post on Facebook and you say, hey, I just saw this really cool system from Stepcraft. Click here, and then you put the URL that we assign you on the website there. When the person clicks that URL, a cookie is placed on their computer, and that person is automatically assigned to you for a period of 45 days. So if they buy a machine within 45 days, then you are going to get 5% credit for that. So at the end of the month, we will do payouts monthly. If somebody turns around and buys a machine that's $2,000, you're going to get $100 out of it, and that's real money. We will send you PayPal or a check at the end of the month for that. So it's a good way to earn some extra money without having to do anything, really. You don't need to sell. You don't need to get online and do any hard pitches. You certainly don't want to spam forums and things like that. But just as you mention Stepcraft and you use that URL, whether it's casually on Facebook or Twitter, or, I have some people that are actually looking at it as a part-time business, and they have put together a blog and, using Twitter and Pinterest and all these different formats to use that URL and try to get more people buying Stepcraft machines. And so far, we started it last week. We've had 2 successful affiliate sales, which was awesome. And I'm hoping that we will, get a lot more people involved. And again, it's free. All you have to do is use the URL, recommend that people purchase our system, and you will get 5% of the sale just for helping me out and helping spread the word about Stepcraft. So anyway, that's all I have for this week. Well, actually, it's not true. I have a lot more, but I try to keep these podcasts around a half an hour. So I will record another one here in a few days, and we'll release it early next week. But to all of you listening, either before Thanksgiving or on Thanksgiving, please have a terrific holiday. And again, I appreciate you listening to the podcast. And if you would be so kind as to go to iTunes and rate our podcast, I would really appreciate it. I will put a link on the website that'll take you right to that spot to rate it. And if you have any comments or questions or anything you'd like me to cover, please reach out to me. Go to the podcast and for the show notes at youcreatepodcast.com/008 and leave me a comment. Let me know what you'd like to hear. I really appreciate it. Okay, everybody, have a great week, and